Uh, so here, what we're going to solve for is these final velocities. So we can do some rearranging. We can say that our v2 final is equal to m1 v0 minus m1 v1 final over m2, just by doing a little bit of algebra. And then we can take this value and plug it in to our kinetic energy equation. So the math involved here is very straightforward, but it does get kind of messy. Actually, we have a half in every term here, so we can just cut out that half to make our lives a little bit simpler. We have m2. Okay. This numerator has an m1 that we can factor out. So m1 v0 minus v1 final over m2 squared. Oof. All right. Again, as I said, not very pretty, but we can work through this. We go ahead and distribute this squared. We've got an m2 in the numerator and an m2 squared in the denominator. So we have an m1 squared over m2. And we've got v0 minus v1 final squared. So if we FOIL that out, we get v0 squared minus 2 v0 v1 final plus v1 final squared, all times m1 squared over m2 squared. Let's just bring everything over to one side, because that'll make it easier. Alright, so we've got this nasty thing. Alright, now this is yucky algebra, but we can work through it. I'm just going to go ahead and distribute everything. v1 final squared plus m1 squared over m2 v0 squared minus 2 m1 over m2 v0 v1 final plus m1 squared over m2 squared v1 final. Yeah, how's that? Alright. To make this a little bit nicer looking, well, first off, we can cancel out a factor of m1 off of everything. And then to make it a little bit nicer, I'm going to multiply through by m2, and I'm going to group like terms of v1, this should be squared. So if we have a v1 final squared, and then I'm multiplying through by m2 also, so we've got a v1 final squared here, that's an m2. And then when I multiply through by m2 here, this is just a m2 plus m1, v1 final squared. Okay, then plus, let's see what we have for v1 final. We're multiplying through by m2, so this one becomes, that's squared, never mind. So we just have 2 minus 2 m1 v0. So that takes care of our squared and our v1 final. And then our last term, we have, what do we have? The ones that don't have v1 final, we've got a plus m1 v0 squared plus m2 v0 squared. So that's v0 squared times m1 plus m2. This is a quadratic in v1 final. So to solve that, we go negative b, so negative negative, so that's 2 m1 v0 plus or minus square root of b squared, which is 4 m1 squared v0 squared, minus 4a c which is all of that. I think I made a sign error. Oh, right, this is minus. So it should be m1 minus m2. m1 minus m2. Okay. All over 2a. Ouch. Okay. And so this gives us v1 final equals. So v1 final equals 2 m1 v0 plus or minus. Now let's look at what's inside this root. Root 4 m1 squared v0 squared minus 4 v0 squared times m1 squared minus m2 squared. That's what we get when we FOIL out that binomial there, over 2 times m1 plus m2. Alright, so this is a 4m1 v0 squared. This is a minus 4m1 v0, all squareds. So underneath the root, we're just left with this part, this 4m2 squared v0 squared over 2 times m1 plus m2, which leaves us with 2m1 v0 plus or minus 2m2 v0 over 2m1 plus m2. 2's cancel out. And we can factor a v0 out of the top. We just have v0 times m1 plus or minus m2 over m1 plus m2. Ooh, so that was really nasty algebra, but this is a reasonable result. The plus would give us that v1 final is equal to v0, and that is the case where there is no collision. So the plus means no collision, and so we ignore that, and we can use our result v1 final equals v0 times m1 minus m2 over m1 plus m2. Wow. So that was some nasty algebra that you probably didn't care to know about, but there it is. And then going back to what we originally substituted in, our v2 final is m1 v0 minus m1 times v1 final, which is all of this junk, all over m2. Okay, so this is fun, right? So we can factor, if we factor in m1 v0 out of the numerator, technically it's breaking. If we factor in m1 v0 out of the numerator, then we just have 1 minus m1 v0 times m1 minus m2 over m1 plus m2 over m2. Let's multiply through by an m1 plus m2. m1 v0 times m1 plus m2 minus m1 whoops, I factored this out, so this m1 v0 shouldn't be here. Okay. Minus m1, it's minus m1 minus m2, so the negative distributes, that becomes plus m2. m1's cancel out. And then in our denominator, we have m2 times m1 plus m2. We multiplied the numerator by m1 plus m2, so we have to multiply the denominator by m1 plus m2. So, in our numerator, we have 2 m2 times m1 v0 over m2 times m1 plus m2. m2's cancel out, and then the result that we can use at our v2 final is 2 m1 v0 over m1 plus m2. Okay, that's a lot of nasty algebra that you don't really need to to know how to do, but the result is important, that these equations are equations that can be used for elastic collisions.